Intel's next-gen processor Panther Lake brings to the table new AI capabilities. I'm Alejandro Hoyos, and this episode of Talking Tech, we're going to be taking a closer look of how AI has reshaped the way we work, how AI workloads are moving from the cloud into your PC, and also what we can see next. Join me on the road to Panther Lake.
The AI PC comes from years of work. First, to build the hardware footprint with a CPU, GPU, and a power-efficient NPU, and then scale that so ISVs can see a way to develop features that get to market. We then develop the tools like OpenVINO that make it really frictionless for ISVs to do their coding in our framework onto an IA AI PC. And then lastly, we're working really closely with the OS vendors to make sure the work they're doing at the OS level can also run best on Intel's AI PC.
So I lead a team of software engineers who focus on AI PC. We develop foundational capabilities of software, starting from the bottom layer, which is closest to the metal, the drivers and firmwares, and libraries, low-level compilers, as well as AI framework. We also partner closely with OS vendors like Microsoft and accelerate their amazing Copilot features. So the team has amazing visibility from workload all the way to how to accelerate on our amazing hardware. So it's a very good vantage point to look at the entire system and how to accelerate AI workloads. Yeah.
To begin with, we had pretty good vector and matrix multiplication capabilities already in the core, used for even the non-AI usages. And when AI buzz actually started, those engines could be used for that. And actually, we started with that. And x86 is very broad. Writing application to x86 is simple and easy, and those applications actually exist. And the core really was able to cope with some of it. The buzz continues, and we want to have even a better accelerator, which is more efficient and more domain specific, that does those specific tasks in the best way that exists. And therefore, we went broader and brought those capabilities into specific accelerator that we have. We have the neural processing unit already starting in Meteor Lake timeframe, and then evolved, and the engine is growing and is more and more capable, and one of the more capable engines that exist out there in the client market. Together with that, what we did is we also added GPU capabilities for AI, that you can call it competing, but it's also a complementary solution. And therefore, when you bucket all of them together, the core ability to do AI workloads, the graphics ability to do AI workloads, and the NPU one, you get a broader set of hardware engine that can cope with multiple type of application and usages. And as we all know and learn along the years, there is no one engine that fits all. There's application that dies for latency. There's application that wants a very high bandwidth and very high compute. And there's application that wants AI, but to do it very efficient. In order to do that, we have a broad set of hardware, as I described, that meets all of those requirements. And we continue and enhance those. And this is our current client strategy.
So we have some specified engines in there to help with those workloads. We have the 3 engines. How does these 3 engines help all those AI workloads?
Yeah, excellent question. So we have what we call XPUs, CPUs, GPUs, and NPUs. Mm-hmm. Going with the previous conversation that how AI is getting into all kinds of software.
Right.
No matter what, whether you are a gaming, which is using GPU, or whether you are using CPU to run, all these engines need to run now some kind of AI workload at the end of the day. So from that point of view, we have invested in AI assets in each of the compute engine, right?
Right.
So that they can accelerate these new generations of workloads. So NPU is really good at doing inference with low power.
Right.
Graphics is a big subsystem by itself. It does 3D, it does media, it does display, and it also does AI. So it comes with a lot of complex assets, whereas NPU is focused and optimized for inference. Because of that, it can be very efficient. When it comes to energy per inference, NPUs always come ahead, right? And the CPUs are always running the traditional workloads. They are good at something which needs low latency because the models are small, submission cost is very less, and you can submit and you can get an instant response. So all three engines have their pros, and they also have limitations. So the trick for the software team is to figure out how to take the advantages of all this and deliver the experience.
We have like a diverse set of applications that are meant to use for AI. Those have different type of requirements. If you're very latency sensitive, if you have short compute cycle, it's usually very good to do this compute on the core. If you want to combine AI usages with additional general purpose type of compute or task, the core is very suitable for that. If you want a big compute engine that does a high amount of batch operation for a long time, the graphics engine is pretty good for that. And if you want to do a background AI operation that your PC will do, and on the background will do a lot of calculation and work for the user, then NPU can be, although very powerful, can do a lot of those usages in the background, consuming much less energy. And is very suitable for those cases. So I would, while it's not 100% accurate, I would categorize that in such a way.
At the end of the day, when people say, "Hey, what's an AI PC?" For us, it's educating them to say it's a CPU, it's a GPU, and it's also the NPU. The NPU is that new piece that I think a lot of people are still learning. And for us as a neural processing unit, it's a different way of learning and understand how do you want to write code to it. It's designed as a much more I'll say power sipping application and low and steady to get the work done, and fantastic at matrix math. And so in that sense, things like security applications we found are fantastic for that, right? You don't want that security app to be spinning up and spinning down, right? It's disruptive, but rather in the background sipping power and really kind of dovetails really to not be in the way of how people work. And so for us, the AI PC experiences, we think, again, this is the future. This is how all PCs will be going forward. And it's a matter of helping developers learn how to use all these pieces to best fit the experience we're looking to build.
We are doing a lot of software and hardware co-optimizations to support this emerging all kinds of different AI workloads. So it includes multiple different components. From the hardware side, we have CPU, GPU, NPU, and on top of that, we need firmwares, we need the drivers, and that will translate the high-level instructions into the detailed hardware level of execution. Then on top of that is software layers and framework and pipelines.
One of the things that we've kind of realized is software fundamentally is very, very important to Intel. As much as we're a hardware company, the realization is it's the software that causes a person to want to buy a computer, right? In terms of, I have a certain task I need to do. I need to play a game. I need to go solve a problem. And this is one of the things where we work very closely with that software system to make sure that their software solutions are able to take advantage of that hardware. And so we purposely work very closely with a wide range of companies to explore, to figure out what they can do and highlight and feature and really showcase what is possible on our platform. A former manager of mine once commented, hey, without software, we're just little heaters. And so really the intent is how do we fundamentally make these more compelling with that hardware and software experience.
Even though we have some great engines, at the end of the day, the software is kind of like the backbone of
Yes.
how you're going to be able to get all these models from the data center into the PC.
Correct.
How can we do that from a software model? Like which layer do you start working with, and how does it go from there?
Yeah. So if you take so the AI models are like a skill set. Like a model can do pretty good job of classifying stuff, or it can remove the background noise. So these things can be incorporated into applications. Like if I take a collaboration application like Zoom or Teams, they use multiple of these models simultaneously because your background may be getting replaced and the background noise may be getting removed. There may be voice to text note conversion happening. Right. So these models need to be now run locally, right? So when you think about a model today, the size of the model is measured by how many billions of parameters, right? That's where the start of a challenge begins to bring this to the PC. So when I say something is 14 billion, the 14 billion parameters with FP16 or FP32 precision is too big to actually run on a
Yeah.
PC. With most of the time you run into, I don't have enough RAM or
Yeah.
memory to actually keep them loaded. So the first step in this is called quantization. So the quantization is a series of software technique where you take this large data set and compress them by going to lower data formats and various other techniques without losing the accuracy. Because the trick is always, you don't want to remove the whole bunch of data and then you get bad accuracy. So,
Yeah.
so there's a lot of clever technique to go through and say, I can take this, which used to take like 12 GB, I can bring it down to 4 GB without losing the accuracy too much by doing a whole bunch of quantization steps. So that's step one, because it's very important to run on a PC, which is a low resource compared to data center. It's applicable even in data center because they also need efficiency at the end of the day, but there is a lot more resources available to run. Then the next thing you do is you take that model and then you go through graph compilation steps, which helps you get rid of all the unnecessary things. And there's a whole bunch of graph compiler techniques to say that, okay, I take this model, I get rid of the nodes, I combine the nodes, and I basically unroll constants. There's a whole bunch of techniques. So it gets you to a little more efficient state, and it decomposes the whole models into a set of basic building blocks primitives. Now these primitives are the ones what get accelerated in the hardware.
Okay.
So then you need to say, okay, how am I going to accelerate this primitive, whether it's a matmul or some kind of a matrix multiplication, and these things can be accelerated on GPU differently than NPU differently than CPU. So then you decompose them and say, okay, I'm going to run this on this engine in this fashion. So there is like 3 important steps in any local inference, which is quantization, the graph compiler, and then the primitive acceleration at the lower level. So that is where the software magic is on most of the things my team does, right? Is how do you do, we have a very awesome asset called OpenVINO, where we have been building these technologies over the last 6-7 years, and we have learned over time on how to do these things very well. Yeah.
So we have OpenVINO, and that's the kind of the backbone to be able to bring those workloads into the PC.
PC, correct. So for anything which is low power devices, we have laptops and any of the IoT segment. So the OpenVINO is the runtime. It's also SDK, which runs on Windows as well as Linux operating system, right? We have a unified stack. It's also an open source project, yeah.
When we first started this journey for AI PCs, OpenVINO was, I'll say, very young and pretty frank, immature. In the Meteor Lake timeframe, 3 years ago, we had a lot of very open discussions with ISVs. What do you need? What's useful for you? What features and parameters would really help make your job easier for how you actually want to enable for an AI PC? And in those 3 years, we've taken that feedback, incorporated it, and really helped developers take that and mature their applications. OpenVINO today is amazing. It's fast, it's performant, it's really able to give developers what they need access to across all 3 XPUs, so CPU, GPU, and NPU. In that sense, it's making their jobs easier. And to be able to easily switch and target which ones you want and get to the right workloads quickly, it's really, I think, become a favorite choice for developers. And so majority of the ecosystem we've enabled is on OpenVINO. And that's one of the things where we're excited and we want to make sure that they're able to get what they need going forward to be successful. Giving developers access to these AI PCs is one of the things we profoundly want to focus on as well. Intel has a focus called the AI PC Dev Cloud. And this is an example where developers can get access to current AI PC units in the cloud. And think of it as a try before you buy. Try out the software that you want to install in these units, see how well it works across your CPU, GPU, and NPU. And that really is a way to just, again, help people understand what's possible before they make their investments.
Yeah, so OpenVINO is open source and you can actually have different OS. So you have that as one of the layers.
Yes.
But then what goes on top of that? Like,
so there is, with any new technology, it takes a while to standardize. So the initial set of challenges we had is a lot of fragmentation in the ecosystem. but slowly things are starting to coalesce. We have been partnering very closely with Microsoft on their WinML. So WinML is one of the API layers for ISVs to standardize across hardware vendors. So what it does is it does a very good job of giving a common infrastructure for all the app writers, but still has the benefit of OpenVINO under it, because we have an OpenVINO execution provider as a backend to Windows ML. So we will have our execution provider, which is like all the years of work we have done, will automatically be leveraged by Windows ML. So for Windows PC, we are going to bring in a very powerful inference software.
Intel and Microsoft partnered with Windows ML as a way to provide kind of, I'll call it, a next generation AI framework. How do we provide a framework that makes it super easy for developers to span a number of hardware platforms? So the intent is, again, every ISV that we've worked with software, they want to make sure they can hit as many devices as possible, right? Everyone wants a large TAM. And so in that sense, we acknowledge that, nothing wrong with it, and we want to help make sure that they're able to do that successfully. Now, having said that, Intel has worked very closely with Microsoft to make sure you are seriously, as a developer, going to have a really rich experience. If you look at what's there, Intel has spent a lot of time and energy to make sure it is by far the most robust, and we're proud of that. And so again, it lives side by side with OpenVINO. A lot of the OpenVINO VITs are part of Windows ML, so it uses the OpenVINO EP on the underlying layer. A lot of the engine parts are also OpenVINO, and so again, you're arguably getting best of both worlds. And so if that cross-compatibility is so important to you, fantastic. Windows ML is a great solution. But this is also one of the things where we've worked very closely with Microsoft to make sure that it is robust for what people need. For us, there's a lot to say between how we work with operating systems and software providers out in the real world. Intel has a wonderfully deep relationship with OS providers. So from Microsoft to Google, a lot of attention is paid and very, I'll say, meticulous and long-term planning to really make sure that enough attention is paid to how the experience will work. Understanding the hardware is going to affect the software is going to affect the hardware. And so making sure that that aspect is there for those devices. Whether it's at the driver level firmware and then how it affects the hardware and then all the way above. We've been spending a lot of time with Microsoft, for example, working on their new Windows ML AI framework that just came out recently. And this is one as an example where we're proud to be lock in step with them to really make sure that whatever AI framework somebody chooses, they're able to have the best experience possible on Intel device. And so in that sense, we try very hard to work across the board to ensure that best developer experience. On the software side, beyond operating systems, we also work closely with AI frameworks like a PyTorch or other levels of software to really make sure, again, it's super easy for developers to have that experience. One of the things that we want to make sure is, at the end of the day, it's not painful, that you actually get your code up running quickly, and that it's going to be the most performant experience that you can get on an Intel device.
You talk about the ecosystem and how fractured it is. How has it been to bring this whole ecosystem together and get it up and running, going in one direction?
So we work with a huge range of ISVs across the board. So worldwide, everyone in North America, China, Europe, take your pick. And it spans across consumer, commercial, gaming, all segments of software. And really the intent is to really make sure any software out there is going to work and have a fantastic experience on the Intel platform. An ISV is an independent software vendor. And so for us, that basically means a large company, could be a Microsoft, could be an Amazon, could be a Google, and working with them to fundamentally help make sure that their software experience is going to run best on an Intel platform. And that's regardless of the operating system. That's regardless of the frameworks. That's regardless of whatever AI capabilities they want to use. But really, it's just fundamentally understanding what that end user experience should be, and we work very closely to help make sure that comes through as part of that enabling effort.
We work with a lot of customers like OEMs and AI solution providers and all kinds of different partners actually to build AI software stacks that can run well on Intel platform and drives the best user experience of Gen AI solutions on Intel platform.
Intel spends a lot of time and focus on the greater ISV ecosystem. And for us, that's working with the large ISVs, what we'll call the top 200, as well as the small new upstarts, startups that are coming up that really are doing amazing, innovative things. The large one, I think, fairly makes sense. Again, these are what a lot of the Fortune 500 companies, people know, game on, depend on for their daily productivity. And these companies are very close partners of us that we work with, very much embedded software teams. There's a lot of trust to show roadmaps and make sure that we're able to really get deep and make sure that new features as well as triaging current bugs and issues are really quickly addressed to make sure there's the best operating experience going forward. The second part I'll say that excites me a lot is the startups. The startups is where a lot of the fun happens. And these are folks taking big risks, crazy ideas, move super fast, and their ability to innovate is just at a different pace. And especially in this AI world where a lot of them are driving these cutting edge, we're super excited to kind of help feature and highlight these appropriately, get them on board our platform, and really figure out how do we give them a good spotlight, right? I mean, there's a wonderful mutual benefit for both of our companies to say, hey, how do we really make sure that we can give them the light of day when they're trying to drive new innovation in that space, and that's something Intel is very proud to support.
From a user perspective, right now it seems like, well, everything it's on the cloud, everything's a data center, everything seems to work fine. Why pose this question of bringing this to your local PC?
Yeah, no, that's a great question. So if we step back a little bit, the AI algorithms have been there for a while. Like this we call classical AI. These are simple things like recommendation systems. You go to a travel website, it recommends where to go, or you have a video streaming or audio streaming, they recommend based on your previous usage of the services. So now what has happened with neural networks, so these things have gotten lot more smarter, right?
Right.
So it's gotten feature rich. So from that point of view, if you think the software as we know it is changing, the existing software we use on the PCs are getting injected with AI. To some extent, the software, reasons for the software to run on the PC, the same reasons apply to AI.
For a lot of people, when we talk about AI, we always refer to cloud AI. In reality, is we see more and more powerful Gen AI solutions and user experience and are showing up on the edge side. So there are a few aspects to it. Then number one is hardware, right? How do we run all kinds of AI workloads, right? It takes a layers of hardware, firmware, drivers, software, and framework all co-optimized together and service all these different kinds of AI workload. The second point I want to make is a lot of these AI model vendors are making a ton of progress on AI models, including smaller size of large language models that are very capable running on edge devices. I have been talking to a lot of different enterprises and consumers. So from consumer side, for a lot of these industries like legal and finance, a lot of data and it's very sensitive and you don't want to just expose all that to the cloud. And a lot of these enterprise people, they want to have full control of the solution. So that makes edge to be a favorable devices and all that to help protect the data privacy, user privacy.
Whether it is about instant responsiveness or control over privacy or even the cost, because a lot of professionals who use AI services pay by the token today.
Wow.
So when you have a lot of the tokens generated locally on your PC, there is a cost angle as well. So these reasons which existed for normal software also exist for AI-based software.
There's a word there that you mentioned, which is token.
Yes.
Which is, for those who are not used to AI, what does a token mean?
So the token is basically a currency. So when I think about token, when it comes to a reasoning models or any models now, generative models, where you are interacting with it. It's like a human being, you ask a question, it gives you answers like a question. So whether the inputs you give, its units are like measured in tokens because you are giving a sentence and approximately each character can be a token. But the output it responds is also a token. So with reasoning models, what is happening is the token rate has gone up because now it's not only giving you an answer, it's telling you how it is thinking about when it gets to the answer.
Okay.
So the tokens have gone up 10x. So if you're paying by the token now, the cost has gone up.
That's I guess pretty expensive.
Right.
So I guess to kind of recap, one of the reasons for moving into the PC, all these workloads, you were talking about like cost.
Yeah.
Also, you took it privacy.
Yeah.
And also, I guess sometimes connectivity, because not always.
Connectivity, correct.
Yeah.
Anytime there is a no connectivity, you want to continue to be productive on a PC, right? It is a big benefit there as well. Yeah.
AI, I think, is one of those amazing new innovations we've seen in the last couple of years. Before AI showed up about 2-3 years ago, most of our innovation has been focused on the CPU and GPU, wonderful accelerators that we have. AI has kind of rewritten the way we actually want to work in the space. And there's I'll call it an awakening that's happened. ISVs are learning how to work with these new features, how to take advantage of the hardware, and not just port their features, but rather invent new features. In that sense, I think Intel's been on the forefront of really helping to encourage, making sure that they have what they need through OpenVINO and other frameworks like Windows ML. And really the intent is, again, how do you make it easy for them to do their innovation? We see this huge opportunity as, how do we make the client even more relevant to the side when it comes to security and manageability and privacy and IP protection. That AI, I think, is still struggling to figure out how to do it safely. And that's absolutely where we see there's a great relevance for the PC client to play.
With technology like AI, what is happening is the pace of innovation is picking up faster and faster.
Yeah.
Because of that, there's always going to be new. Now the big thing is agentic.
As of today, we already see the industry is moving from just the answer engine, AI as answer engine, to AI as the agent engine. So what does that mean is in the past, when we talk to this AI bot and you ask a question, it answers. But now it doesn't only do that, but also performs tasks for you. And so at Intel, and we built this reference design called Intel AI Assistant Builder or Super Builder. And we also, evolved from just provide answers through AI and running small large language models on devices to today. And we just announced this actually at IFA in the beginning of September. We can support multi-agent orchestration through MCP framework. MCP stands for Model Context Protocol. And what that means is with this new framework on device with AI PC, and this AI will take your query text prompt and decompose into different tasks and performs the tasks for you.
Right, the agentic revolution is starting, and the amount of software and standardization there is still new, right? There's a lot of work happening there. So I think how the technology goes in these waves, right? You have a whole bunch of new things and it gets standardized and something else comes on top of it. So right now, even though the inferencing stuff is getting standardized slowly, now the agentic stuff will come and it will create a whole bunch of new opportunities. Yeah.
So when you thought that the party was slowing down, and agentic came over, and now it's like start all over again.
Yeah, that's the beauty of technology, right? We build complexity and then abstract the complexity and build the next level and the next level, right?
Yeah. No, it's amazing, and I'm actually very impressed. Like, I know technology moves fast, but this whole I don't know if we could call it AI revolution, but how AI has come, and I know it's started back in the 60s with image
classification, computer vision. Yeah.
It started a long time ago, but like in the last, 5 years, it's been crazy.
Yeah. I think the thing is the ChatGPT movement happened, and suddenly it opened up a lot of people's imagination that the interaction is almost human-like. Right, so it can start to reason and think on new information, right? Yeah. So with that, what has happened is now, what previously the interactions between two software used to be based on APIs. Mm-hmm. Now it's getting replaced with prompts, right? Now the pace of innovation is faster. Previously, a pace of innovation was tied to how the APIs are getting evolved and getting standardized, which takes time. Now, if you say that all the interactions are happening on a prompt, like you send a prompt and the other system responds back, then it opens up much faster innovation cycle.
What most excites me about Panther Lake is, at the end of the day, it's more, and it's amazingly more for what you actually get relative to the innovations we've seen in Lunar Lake. Lunar Lake for us, I think, was a really nice step to say, wow, performance and power. And Panther Lake, I think, takes that and just knocks it up a couple steps. And so the more powerful cores, a little bit more NPU, and the part that gets me most excited is the GPU. I think people are going to be impressed. That's a serious next step that we've seen that is going to take, running AI on the client, running LLMs on your device to a whole new level that I think people are going to be seriously excited with at this point.
Panther Lake is going to take all the work we've been doing over multiple generations, and we're now going to be able to scale it in a very systemic way with our OEMs across their mobile platforms.